Welcome to Engineering and STEM Learning in Summer Programs and Beyond. Thank you for joining us in the afternoon or the evening, whatever it is for you. I appreciate you stepping away from NCAA brackets and lots of other exciting, important things to be here. Welcome. All right. My name is Carrie Baldwin. I'm a professional learning and outreach manager for the Museum of Science Boston for the YES team, which stands for Youth Engineering Solutions. I've been in this role for about 2 years. My job is to help train teachers on our engineering curricula, to help educators and teachers know about our engineering curricula. So folks who do out of school time programming, summer programming, school time programming, etc. Before that, I was a science teacher for 10 years, a middle school and high school science teacher, and also worked as an instructional coach at an AmeriCorps program called City Year. So welcome. Please, if you feel comfortable, please share your role just to see kind of who's in the room in the chat, and we'll try to check that out. All right, so our goal is by the end of this session, you'll learn how to use our free engineering curriculum in summer programs and other out of school time settings. Um, you will learn some ways to build youth problem solving, teamwork, and critical thinking skills. And you'll also see how our new career explorations that go with some of our enrichment units connect hands-on projects and that hands-on engineering to real-world careers. All right, so our agenda is to do a quick overview of YES, talk about STEM in summer programs and beyond. I want to share the YES units, the enrichment units that are available for free download, share a little bit about career explorations, and then leave time for questions and wrap up as well. All right, so I just want to share a little bit about, some of you may be familiar, but just wanted to share a little bit about the YES approach. So you'll see in this sort of pie chart, we have some of the different dimensions, the different things that our curriculum team puts into every unit. So some of those key things are making sure that there's a problem that students are drawn to. So a socially engaged engineering, there's a problem that they're there to help solve. There's authentic engineering practices. There's asset-based pedagogies, which just, means that we're thinking about what students already know and what they already bring into the space. And we're making sure they have resources like glossaries and vocab cards and engineering notebooks available to them. And that over time, we believe if you keep doing these things and keep that in mind, that over time you'll help build students' engineering identity. So we really want to make sure we're building students' problem-solving habits, their collaboration and persistence, and we really want to help students see themselves as engineers and have that engineering identity. So we are a team that works out of the Museum of Science in Boston. We're the curriculum division. And our mission is to help help support the next generation of problem solvers. We have a number of products. We have YES Middle School, we have YES Elementary, we have YES Enrichment, which is summer programs, after school. We'll talk more about that. We have We Engineer, which is a preschool program, and we have YES STEM, STEM event activities, which is new. And so if you're looking for support with an event, a STEM night or a STEM fair at your site, that is something definitely to check out. All right, so some things that we have available are in all of our units for free download. We have an educator guide, which we'll talk more about. We have teach slides that are student facing. Google Slides. We have how-to videos, both for the educator in terms of setup and for students to help see how to do the testing. We have vocabulary cards, materials glossaries, and family resources like a family letter. You can also, on our website, purchase the materials kits. If you have if you have funding through your organization or you have it through a grant, that is a great way to go, just to have everything in one place. But if that's not possible, we also supply lists of exactly what you need for different units. All right, so we focus on the engineering design process. It looks different whether it's preschool, elementary school, or middle school, which makes sense developmentally. So it definitely gets more complex as youth get older. And the one thing I kind of wanted to zoom in on is out of our wheel of principles is really those authentic engineering practices. So there's a lot that we list. We list 16 authentic engineering practices that we want to be a part of our units. Not every single one shows up in every single unit, but the goal is to get have as many authentic practices as possible over time. And so some that stand out a lot, I guess to me, are that I see a lot are considering the problem in context, exploring properties and uses of materials, using a structured process, making evidence-based decisions, working effectively in teams, communicating effectively, and envisioning multiple solutions. So I'm hoping these clips work. If they don't, please let me know in the chat and I'll try to restart it. But what I'd love to show you is this is a scout troop who are doing one of our enrichment units, our sales unit for lower elementary age. And this is a clip of that engineering practice of assessing implications of solutions.
Okay. And mine was to put a cell on the bottom and put on both of the sides. So how many sails are you thinking total, Kat?
3.
3. And Summer's thinking just 1.
Like 1 would be faster because 3, the wind might push it different ways.
Okay, so the wind might move it all around?
So like,
yep, go ahead.
This part with like if 1 was here, 1 was here, 1 will go forward and 1 will go backwards.
Ooh, so
and
might...
then it wouldn't move. I picked 3 because it could push up more, so it would go a little bit faster, except not too fast that they would spin.
All right, try to move on to our next one. All right, so with that one, assessing the implications of solutions. Something that we have in our educator guide and we want to push students to do is asking youth questions to get them to think about the implications of their design. What are the benefits of their design? What are the potential drawbacks? Are there trade-offs? So you can ask questions like, who is this design helping more? How might your design choice not be helpful for certain users? Can you think of something that might happen because of your design choice? All those kind of different questions. All right, so we're going to see one more. Another one that is my personal favorite is the practice of persisting through and learning from failure. Persist through and learn from failure. And so in all of our comics and in all of our short stories, we always have a situation where the characters at some point are basically hitting a wall. They're failing in some way. Their design, I shouldn't say their design is failing in some way. And so it's not working the way they expected. Some things are working, some things are not. So we always have this to happen to our characters because it happens in real life all the time. And certainly happens in engineering. And so we have a phrase called flip the failure. So that's something we really want to help students practice because it takes a lot of time. It takes a lot of support to start to view these things, these setbacks as a learning point. So I'll show one more. There we go. And this is a group in an after-school program in Puerto Rico who are talking about the engineering unit they just did.
How did you flip the failure today? How did you work on it?
We took out the weights and we added another.
In your mind, how was your mindset? It was positive. It was negative.
Positive.
Huh? For the teams that didn't arrive on the target, how do you felt?
I didn't think it was gonna be that hard.
But what happened in the instant? Do you stay like down, like you don't want to do it again? So what your mindset was?
I'm gonna do it again. I'm gonna try again.
Very good. So the same thing happened in the comic. They tried it again and again. And this happens all the time with scientists and with engineers. Not everything is gonna be perfect at the same time. And it happens to you every single day, right? Every single day you have to have a good mindset. What changes did you make to get your shuttle to land in your target zones?
We took the weights and added one fin because we thought it didn't go so far because of the weight that was putting it down, and also because.
So you make it more lighter and place just one wing, more fins. Do you have fun today?
I give today 4.2 of 5.
Out of 5.
Let me see. I like that, the 4.2 as well. All right, let's move on. So I encourage you to think about your own context, your own program, and some ways that you see these engineering practices benefiting youth in your program. All right. So we know, so you probably want to talk about sort of what is enrichment. So we use that word a lot with our curriculum. It's a whole line of products. So when we say enrichment, it's basically we use that word to explain anything that's in the out of school time. So it's summer programs. So summer school, summer programs, STEM classes, after school clubs, events at libraries, scouting, all of those different things. It could be school vacation camp. So any of those different things, we consider basically to be an enrichment situation. And so there's this organization called the After School STEM Hub, and they share information. They share information about after school and out of school time. And one of their most recent fact sheets that came out showed that as many of you know, learning doesn't just happen in school, and that about 81.5, almost 82% of time is spent in informal learning environments or outside of school. And students, spend, more than 80% of their waking hours in these other settings, after school, summer programs, libraries, etc. And so it says after school STEM, but we're going to kind of expand that out to all of these after school and out of school time programs. We know that fostering STEM skills like inquiry, reasoning, and problem solving happens through hands-on engagement. We know it exposes students to STEM careers, and we know that it can help increase the pool of young people engaged in STEM, especially those folks who are typically not in STEM programs. And then the benefits of having STEM in these enrichment spaces, they foster positive youth development and a sense of belonging. They help close those opportunity gaps, and also just lead to higher STEM career pursuits as well. So some of the benefits of our enrichment curriculum, things I feel are really important to share. It's effective in a variety of settings. So again, all those different types of settings. It's great for youth with diverse backgrounds, experiences, and abilities. There's scaffolds built in, there's supports built in to help with language development and recording their information, all of those things. The educator guides provide step-by-step directions. So they help you, they provide step-by-step directions for the educators, and they also allow you to meet the needs of individual youth. They're flexible. There's 5 core lessons and 4 optional lessons with each of the units, and you don't need any prior science knowledge. So the way the units are constructed, I just kind of share this, but again, there's those 5 core activities. They're about 45 minutes each, and then there's 4 optional lessons as well. So I'm going to kind of shift to just talking about the actual units, give you an overview. It'll be a quick overview of the units, and then talk about the careers. So in the engineering rescue shuttles, which is an upper elementary unit, it's students design a shuttle to land a rope near a person who needs a water rescue. And so they're testing different shuttle variables, like the number of fins, the weight and the position of the weight, the type of material it's built out of, and the length of the rocket body. And they're using it to help land in a certain area to rescue a certain group of folks. This is the actual, just a sheet from the overview. It shows, so the educator guide again has sample questions that you can ask students. It also has teaching tips, and it also has specific information about what needs to be prepped for each lesson as well. Things that are available in all of the units are a comic to kick it off. That kind of sets the stage for sets the stage for the design challenge. And these are just examples of some of the different educator slides. They're available on a Google Drive, so we share that off of our website. I'll show you how to get there. And then these are available. You could just download them to your computer, and then you can change the information on them to meet whatever you want. So here's an example. These are from the engineering notebooks. So this is from the rescue shuttles. I found this one yesterday. I just kind of like the washers on here. It looks like eyeballs. And so their student is drawing or writing their ideas. And then they talk about what they learned from creating rescue shuttles. And then also this other one over here that's Imagine Bags. That's actually one of the optional lessons where students design a waterproof bag for these water rescues. All right, another one, upper elementary, is engineering upcycled toys. So students design a toy vehicle made from upcycled materials, and they explore how different variables affect the stability and the distance traveled. So the comic book introduces Kai, who's opening an upcycled toy store and needs help engineering toys with wheels. So we go through that. There's a bunch of scaffolding lessons. So students explore different wheels and axles. They learn how to create wheels that can travel far and toys that can go over bumps. So here's some more pictures. So you can see there's the wheel and axles. And then there's directions on and some videos as well for how to do the testing. The top right corner, that shows the ramp that you built and a vehicle going down it and over one of the bumps. Then students determine the type of vehicle they will engineer. Are they going to engineer a car, a carriage, or a cart? They all carry different amounts of things. So they decide that. And then they imagine, plan, create, test, and improve their upcycled toy. So using out of the materials you can see there on the left, they're able to go through that process. There's also some optional lessons at the end where they can design a different upcycled toy, and they can also do a design packaging for their toy as well. Another upper elementary unit is engineering an assistive device, or we call them sock aids. And students design an assistive device that helps people with limited mobility to put on their socks. And so there's a comic about a student who has injured her leg and she has a cast on and she's not able to reach to put on her socks. That sets off the story. They really explore how different assistive technology solves problems. And so in this one, they go through the lessons and they are scaffolding lessons for how to, what are the steps when you put on a sock? Like what are the actual, let's break it down. Then they go through, prepare for step 1, putting on a sock by designing something to hold open a bag. So just like you would pull open a sock. And then they prepare for step 2 of putting on the sock by engineering a device to pull a pillowcase on. And they then use that information to design this assistive device that can help someone pull on a sock and then, pull a sock the whole way on and then remove the device from the sock. What's cool about this one is there's also optional activities where they can engineer another assistive device, like a common household utensil, and they can also dig into the accessibility of different spaces around their school or their community center. All right, so we're gonna skip to middle school. The middle school unit we have right now is engineering antivirals. So we're switching to health over here. Students engineer a working model of an antiviral to stop a virus from attaching to a cell. They investigate how viruses get into cells and apply what they've learned to a design. In it, we have a boys volleyball team, Lucas and Corey. Their teammates are all getting sick. They're looking for ways to fight a virus. There's scaffolding lessons. They explore and engineer a model virus that can attach to a model cell. And that model cell is that basically that tube. So it's kind of one of those snow tubes. And it's a pretty fun, it's a really fun unit actually, where they're engineering things that can attach to that cell as well. They learn about antivirus that can stop specific viruses from entering the cell. And they're designing a finished model virus, going through those processes of designing it and then improving for a mutation. So we introduced the idea of a mutation, and that's the part of the engineering design process where they're improving the original design. All right, we're moving to the lower elementary. We have some different options. We have engineering bubble wands. So students design a bubble wand that fits in a particular container of bubble solution and makes a particular kind of bubble. So students really explore techniques for making bubbles and different materials and shapes to make bubble wands. And there's some examples of the bubble wands um, as well. So we have an interactive poster in this case. So it's for the younger students. It's an interactive illustrated poster. So you share the story, different things happening, and then move the characters around on the story. They have friends coming to a bubble party, and they want their friends to be able to make many types of bubbles. So students, again, explore some different techniques about how to make bubbles, and materials that can make bubbles. They consider the type of bubbles each guest would want to make. They make a bubble wand, and then they make a container for it as well. All right, we have engineering sales. So you saw the Scout Troop was doing this one. And in this, students are designing a sail that uses wind to transport collectibles called scoobles across a distance. And they explore how the materials that make up the sails and the placement of the sails can affect its performance. So it's basically a fishing line, and there's a fan, and they're kind of transporting something across that using wind energy. Then we have engineering bandages, and students design bandages that can cover and protect a model cut. So they learn the different parts of a bandage, how they work together for a successful design, and explore how different materials can affect the success. So they look at the stickiness of the material. They look at the absorption of the material, and see how good it is at keeping the model cut clean. It's a fun one. Just a couple of notes on implementation, which is true for all of our units. Is one of those is just in terms of an implementation tip is to just focus on the process, not the product. So just making sure that students are, the real learning is happening as they're trying things out, not in a successful final product. They're learning things along the way, and having those moments where things aren't working well and you have to go back and fix it is an important process. You can definitely, there are sample questions in the teacher's guide or the educator guide. You can use them, you can change them. You should definitely modify discussions to meet the needs of your youth. Change the wording, use some, use other ones. And then just, work with students and help support students in connecting the content to their lives. So helping them make those connections from the story or from the different lessons to things that they see in their own life. All right, shifting to career explorations. So some of our enrichment units have career explorations that are one of the optional lessons. This is something brand new. So on here, we have our framework for yes, career explorations. What we have in there is there's integrated STEM and career learning. So they go with our engineering units. They can be used as a standalone, but they integrate. They're meant to be used right after an engineering unit. So they integrate them together. They really focus on durable skills, or sort of those soft skills, like creativity, cooperation, persistence, all of those things. There's choice. We know students want choice when they're doing something and exploring something. And we also want to just introduce them to a range of careers, not just STEM careers. So I'll show you how to get to the website in a moment. On the website, you can go through the unit that it belongs to, or the engineering unit, or you can go to career explorations. And so here's an example of the unit, the explorations that go with our engineering rescue shuttles. And it's all about disaster recovery careers. So on the webpage, you can go to it, and then you click download resources. It says free. That's important. And then what you'll come to is a Google Drive, again, with all of the materials that you'll need, and you can download all of that to your own device as well. So the career exploration comes with an activity guide for that specific exploration, again, with sample questions, tips, that sort of thing. And then they go through some different things for each career exploration. So that there's some slides that present a short, really short information about each career. They watch a snippet or a short part of a video about each career, and then they take a career quiz on their own, and that leads them to two careers that they might want to explore out of six. So this is just an example from the disaster recovery. We have power plant operators keep electricity systems running so people have power, and real estate professionals make sure homes are safe and repaired after disasters. So this is just an example of the teacher slides. So they share, you get a chance to share these. There's the video, so you see a snippet of each video. This is a graphic designer who works with rescue devices and how to communicate to people. This is a picture of the career quiz. And students have a chance to share their preference on a bunch of different things. And then they kind of add up their score. Using all that information, they decide which two careers out of the six they want to explore in this like 45-minute block. If you have extra time, they can explore all of them, but they get a choice to decide what they want to explore. And they're all tied to these career clusters as well, these career clusters from the national framework. The career clusters framework has 14 career clusters. And so all of our professions in these career explorations are linked back to one of these 14 career clusters. And that really just shows that everything is intertwined, and folks from very different professions will all work together to address a problem at the same time. All right, so this is the career scavenger hunt, or the station. So once they decide what to explore, they go to a different station that you've set up. They can either do it, there's a paper version, and there's also a digital version. And what they do is they explore, they start with a day in the life. So they start with something called a day in the life, which is like a choose your own adventure, where they have to they get presented with a problem and they get two choices and they have to decide which choice they're going to go with. And they lead to different results. So they go through a day in the life, and then they have a chance to explore different resources like videos of that profession, read an article about that profession, somehow explore it in some way as well. And then they just record something they found interesting about that career as well. So this is a digital example of the day in the life. There's also a written example, a paper example. These will be in Google Slides very soon. We're transferring them over from something else. But this was an example from the day in the life of an environmental planner. And this is the digital version. So you're an environmental planner. Your team helps protect the environment. A wildfire burned down parts of the local city and forest, and your team is helping with environmental recovery and rebuilding. So you can focus on A, managing the risk of future fires. If so, go to step 2, or B, helping the forest grow back. Go to step 5. So it's really like a choose your own adventure. They could see the results of choices that they make and go back and at the end and make different choices as well to see what that leads to. There's some optional activities that are in there, like make a career poster, which is an option. So this is something that folks have done to kind of expand the unit. There's also an invite for folks to come in. I know that can be hard, but to get folks to come in as guest speakers for certain careers or career clusters. And then there's also a family letter as well, in addition to that. So there's just the different resources, again, like those videos and interviews with different career professionals. And then there's a letter home for family members, because all the folks who study, career exploration share how much families influence the eventual decisions that a lot of students make or youth make about future pathways. So we want to make sure that, families are involved in knowing what's going on, and that students are sharing some of the things that they explored and are interested in. All right. So if you're going to go to our website, we're located at yes.mos.org. You can find the enrichment curricula by clicking Explore Curricula on our homepage. and you can scroll and select the product line you'd like to explore. In this case, we were talking about enrichment tonight, or today. So you can click Guess Enrichment. And then you select the unit you'd like to view out of those ones I give you an overview of. And then all you have to do is click Download Resources. So there's a button that says Digital Resources Free. You just click Download Resources. And then it'll take you to a sign in. We would love you to sign in once, just so we know who's downloading it, since we don't have a great way of keeping track of it. So it's helpful for grants. But if you could, fill it in once, and then after that, just go straight to continue to download. And then again, you'll bring up those folders in the Google Drive, like in this case, the teacher slides. There's the Next Generation Science Standards connections. There's the educator guide. And then there are entire folders of print materials of everything that you need for that unit in English and also in Spanish. All right. Other thing on here, we know how important summer is and summer STEM. So on our website, you can also just explore summer STEM options. And it has some frequently asked questions, things that you might be interested in, but can, kind of give an overview for these summer programs, as well as school year programs. And then I'll come back to the slide in a second. This is just a QR code that can kind of take you there too. But again, everything is located at yes.mos.org. So I'll come back to this one. There's also on our website, there's information about professional learning. So many of you are already connected to this because you're here right now. But you can go to professional learning and go to workshops and webinars to find out what's coming up. We do have some things coming up. So we have our monthly free webinars, and we also have some summer learning. So our free webinars coming up are April 15th. And my supervisor, Shannon McManus, is going to be talking about engineering practices and how those engineering practices support student engagement. We all want students to be engaged. We all want to be engaged. And then May 6th is going to be a focus on what's new at YES. And I believe we'll be talking about a new enrichment unit called Parachutes, engineering parachutes, which is exciting. We have some in-person workshops coming up. If you're able to travel to Boston or you're in the Boston area, those workshops are at the Museum of Science. And the next one that's coming up is June 30th to July 2nd. You can come for all 3 days to get the whole pre-K to 8 overview, or you can choose the day that best matches your grade band. So day 1 is going to be focused on engineering and early childhood. So we'll be talking about We Engineer, the preschool units, and Sun Hats. And then we have the elementary engineering and computer science. And that one is going to be, let me just check my notes here. That one's going to be focused on safety vests unit, and using microbits to make signal bracelets. And then day 3 is middle school engineering. And that's going to be focused on a new unit called Vision Extenders, and a MATLAB website that is actually looking at exoplanets. So it's got a space connection, and it's a free program that students can use, and they help analyze light curve patterns, and that helps detect where exoplanets are. So it's a really cool link to light and optics as well. So I'll go back again to those QR codes in a second, but since this is not the most conducive to asking questions, understatement, this is my email. cbaldwin@mos.org. Also on here is our customer success team. You can reach them at yes@mos.org. They're a 3-person team. They're amazing. If they don't know the answer to something, they will find out from the curriculum team, or they'll come over to the professional learning team. We're all there and can help get you those answers as well. So I hope that you got some information out of this tonight. I would love you to check out the website, check out what's new. And again, please contact us if you have any questions. We definitely want to help as you're planning for summer programs, and you're planning for, after school clubs, school vacation, all of the stuff. We're really excited to do that. So please let us know. And I'll try to hang out here. If you have a question, uh, feel free to stay on and you can raise your hand as well. Thank you.